Hello guys, welcome to an Academy KSET YouTube live session. Myself Sharif, teaching IIT JEE Mains and Advanced Math from past 16 years. Taught math in India as well as abroad. Currently working as head of the math department and vice principal of Giraffe Learning, Bangalore. We have done right before I go to class, guys. Okay, if you are looking for the Unacademy subscription. Right, these are the best plans for Karnataka KSET 2020 aspirants. 12 months it will cost you 12375, that is 1031 per month. Enter this referral code, that's my referral code, Kalim Life. You get 10% discount. 6-month plan it will cost you 10125, that is 1688 per month. Enter this referral code, you get 10% discount, and per month 2250, that's a throwaway price in Bangalore. Enter this referral code, you get 10% discount. It covers the premium content at all affordable price, structured live courses, and plus dedicated live doubt clearing sessions, quizzes at regular intervals for self-analysis, batches for complete preparation, test series for DPP, that is daily practice paper, full and mocks, etc. with analysis, with feedbacks, immediate feedbacks will be given. Single subscription for unlimited access. Right guys, let me remind you at the end of my class as well. So we are going ahead with we were doing PYQs of matrices and determinants. Alright, we have done 39 questions in the first part and the second part. Alright, now I'm going to start with the third part. Okay, part 3. So 39 questions we have done, guys. Forty 49 we have done. Yeah. We have done up to here. Please, if you have missed my previous YouTube sessions, guys, right? Please watch the part 1 and part 2 as well. And if you are new here, please subscribe, guys. Enable the bell icon and subscribe. You get the live updates of my YouTube sessions, YouTube classes, free YouTube live sessions. So we have done up to question number 48. Yeah, right, I'm right, up to 48. So 49 we have to start with. Alright guys. I'm supposed to find out what is determinant of AB. Determinant of AB can be written as determinant A into determinant B. Right, now I'll find the value of determinant A. Determinant A is equal to, right, principal minus secondary. Here itself you get 0 minus 10. Oh, options are not there, is it? Alright, 0 minus 10. So this will be minus 10. Okay, and then determinant of B. Determinant of B is equal to principal minus secondary. You will get this as 0 minus 17. Minus 10. So we simplify this. This will be equal to minus 10 and minus 0. Alright, principal minus secondary, you get this as minus 10. Now I'm going to substitute here, even this is minus 10. So answer will be equal to 100. Alright, so this is 100. Okay guys, let's move to the next question. What is inverse of this matrix? Alright, now inverse of a non-singular matrix. Inverse of a non-singular matrix is equal to A inverse is equal to 1 by determinant of A into adjoint of A. This will be A inverse. Alright, now let me find out first. Matrix A is equal to matrix 5 minus 2, 3 and 1. Alright, now let me find the determinant of this. Determinant is equal to determinant of, you get this is 5 minus and minus is plus, principal minus secondary. I get this is 11. Right? Whenever determinant is not equal to 0, it is non-singular. So A is non-singular. A is non-singular and hence inverse will exist. In case if it is 0, it does not exist. If in case determinant is equal to 0, then it becomes a singular matrix, then inverse doesn't exist. So adjoint of a 2 by 2 matrix, adjoint of a 2 by 2 matrix will be equal to 3 by 3. How to find? We have done in session 1. If you have missed the class, please watch that YouTube session, guys. I have done a shortcut for this, how to find the 3 by 3 adjoint shortcut. If you want to find the adjoint of this, interchange the diagonal elements, okay, and change the sign of other elements. Minus 2 becomes plus 2, plus 3 becomes minus 3. This will be adjoint. Now, if I use this formula, inverse of a non-singular matrix is equal to A inverse is equal to 1 by determinant of A into adjoint of A. Determinant A will be equal to 11, so you get 1 by 11, right? What is adjoint A? Just now we found out, 1, this will be 2, minus 3 and 5. Answer will be option A. 1 upon 11, 1, 2, minus 3 and 5. Is it clear, guys? Yes, Amog Shetty, very good. Right. Okay, guys, let's move to the next. Question number 51. I'm supposed to find out what is matrix B. Right. Now, just like solving simultaneous linear equations. Right. Follow carefully now. Now, this is 2A plus 3B is equal to matrix 2 minus 1 and 4. This is 3, 2 and 5. This is 3A plus 2B. And next matrix will be equal to A plus 2B. A plus 2B is equal to, right, a matrix 5, 0, 3, 5, 0, 3 and 1, 6 and 2. Alright, now listen. Let me call this equation 1, okay, and let me call this equation 2. It's just like solving simultaneous linear equations. I'm supposed to find out B now. I'm going to eliminate A. I'll multiply this by 2. Alright, now this becomes 2A plus 2B. 2A plus 3B, I'm sorry. This will be equal to 2A plus 3B. 2A plus 3B is equal to matrix. Matrix will be equal to 2 minus 1 and 4. And then this is equal to 3, 2, 5. Right? I'm going to multiply this by 2. Second matrix by 2. So this becomes 2A plus 4B. Right? Is equal to matrix. If you multiply by 2, you get 10, 0 and 6. And multiply by 2, you get 2, 12 and 4. Right? Let us subtract. Let us change the sign. 2, 5, 0 and then you get 2, 6, 4. Fine. Alright. If I multiply this by 2. Right. Now what happens to this? Let us change the sign, guys. This will be equal to minus. Right? Even this is minus. Even this will be minus. Let us change the sign. So this fellow is going to get cancelled. Right? Now we will subtract them. So this is minus B. Right? Minus B is equal to matrix. Right? Now let us subtract. 2 minus 10 is minus 8. Okay, minus 1 minus 0 is minus 1. 4 minus 6 is minus 2. And then you get 3 minus 2 will be equal to 1. And then you get this is minus 10. Subtract, you will get this is plus 1. Right, this is actually minus B. But I'm supposed to find out what is matrix B. Right, shift B on the right side and change the sign. So matrix B will be equal to, matrix B will be equal to 8, 1 plus 2. Okay, 8, 1 plus 2 and then you get minus 1 plus 10 and minus 1. Right, that is our answer is option C, option 3. 8, 1, 2, minus 1, 10 and minus 1. Okay friends, let's go to the next question. Alright, very tricky question, think about it. Alright, right now listen. Good question, I like this question guys, very good question. See, if A is a matrix order M by P, if A is a matrix order M by P and B is a matrix order P by N, the product AB exists, matrix AB will exist only when number of columns of A is same as number of rows of B. Then AB will be a matrix of order m by n. That is, number of columns of A is same as number of rows of B. Only then the matrix will exist. Now you have to check which of the following matrices is not defined. Alright. So let's understand the question, which not defined, not the defined one. Alright. Now listen. Let me take the first option. Right. If I take the first option, option 1. C is a matrix, right? It's already given. C is a matrix of order 3 by 3. So let me write this. Right, now A plus B dash is a matrix. Right, addition or subtraction, you can add or subtract two matrices only when their orders are same. So let me take order of A. Order of A will be equal to 2 by 3. Right, order of B is 3 by 2. Order of B dash, take the transpose, guys. Order of B dash will also be 2 by 3 only. So this means that A plus B dash will also be a matrix. Right, A plus B dash is a matrix order 2 by 3 only. So this fellow itself is 2 by 3, no changes. This is 2 by 3 only. So this means that number of columns of first cannot be equal to number of rows of second. Don't cancel this way. You understand? Don't cancel this way. Number of columns of first should be same as number of rows of second. So they are different. So this means that C into AB dash does not exist. This does not exist. Right, answer is option A only. The question, which of the following not defined. We can check the other options as well. Right. See, suppose I take the second question, guys. So C is a matrix of order 3 by 3. Right, now what is AB dash? AB dash is a matrix of order 2 by 3 now. Now if I take AB dash the whole dash, if I take the transpose once again, this 2 by 3 becomes 3 by 2. So this AB dash, right, AB dash the whole dash. If I take the transpose once again, this fellow will be a matrix of order 3 by 2. Take the transpose, yeah, 2 by 3 becomes 3 by 2. Now this is defined. So this means that C into AB dash, the whole dash, will be a matrix of order 3 by 2. Right? Hope you understood, guys. Convinced? That's all. This is defined. Right? Second option is correct. It is defined. Right, now let me check for B, C. Alright, matrix multiplication is always associative. You can group in any ways. Alright, let's say I group these two, or you group A and C, no problem. Matrix multiplication is not commutative, it's always associative. So suppose I take this B into A. Alright, matrix of order B. B is a matrix of order 3 by 2. And A is a matrix of order 2 by 3. Right, obviously this will cancel. Number of columns of first should be same as number of rows of second. BA will be a matrix of order 3 by 3. Okay, now if I take, suppose BA is a matrix of order 3 by 3. Okay, and then A is a matrix, C is a matrix of order. What's the order of C now? 3 by 3. Even this will exist. Number of columns of first should be same as number of rows of second. So this is equal to BA into C will be a matrix order 3 by 3. Even this will exist, guys. So even C is correct. You check, even D will be correct. Alright, first option is incorrect. So which of the following not defined? So first option is not defined. Very good question. Let's move to the next question, friends. Alright, question number 53. I'm supposed to find the value of K. Alright, now first we'll find out A square. A square is equal to A into A. Now this A square is equal to let's multiply 1 minus 3 and 2k. Even this matrix will be equal to 1 minus 3 and 2k. Right, let's multiply. This will be row and this will be column. A square is equal to a matrix. Multiply first row and first column. You will get this is 1 minus 6. That is first row, first column. Next first row, second column. You will get this is minus 3, right? Minus 3k. Second row, first column. You will get this is 2 plus 2k. And then second row, second column. you will get this is minus 6, okay, plus k square. So this matrix A square is equal to 5 minus 5 minus 3 minus k. Minus 3 minus k, this is equal to 2 plus 2k. Let me write properly. Okay, this will be equal to 2 plus 2k. This is 2 plus 2k, and then here you get minus 6 plus k square. Alright, this is a square. Right, now I have it's given a question that a square minus 4a plus 10i, right, is equal to matrix A. Right, so let me find out this. First I'll find out this a square. A square will be equal to minus 5 minus 3 minus 3k, right, and then you get this is 2 plus 2k, and then minus 6 plus k square, right, minus into a bracket 4a, 4 matrix A multiplied by 4, so this will be equal to 4 minus 12, okay, and then 4 into 2 is 8, right, and then 4k, right. I skip one step, guys. 10 into I will be equal to 10 0 0 10, right, and then you have matrix A. Matrix A will be equal to 1 minus 3 2 and k, right. Now if we simplify this, minus 5 minus 4 plus 10, okay, and then you get minus 3k, minus and minus is plus 12, okay, and then plus 0, minus 3 minus 3k minus plus 12 plus 0, so this will be equal to 2 plus 2k, okay. Now this is 2 plus 2k, guys. 2 plus 2k minus 8, right, and then plus 0, you get minus 6 plus k square plus 4k minus 6 minus plus k square minus 4k. I'm sorry, it should be minus 4, right. So this is equal to minus 4. This should be equal to minus 4k, right, plus 10. Plus 10 is equal to a matrix 1, okay, minus 3, 2 and k. Now if I equate the corresponding component, first element will be 1 only. So if you equate, you get the same thing, guys. Now if I equate these two, minus 3 minus 3k plus 12, okay, is equal to minus 3. I'm going to cancel this fellow, right. You get minus 3k is equal to minus 12, k is equal to plus 4, right, one value k equal to plus 4. Even if you equate, you get plus 4 only. 2k minus 6, 2k minus 6 is equal to minus 2, k equal to 4 only. So let me equate these two and check. So let me take up a new slide. So I get next, if I equate that, you get minus 6 plus k square. Minus 6 plus k square minus 4k plus 10. Plus 10 is equal to, alright, what do you have on the right side? Equal to k. So this will be equal to k square, okay, minus 5k. 5k plus 4 is equal to 0. Let's split the middle term. Minus 5, right? So this is minus 4 minus 1. So this is k minus 1, okay, into k plus 4. K minus 4 equal to 0. I get k equal to 1 and k equal to 4. K equal to 4 we already got in the first initial step. So either k is 1 or k equal to 4. Answer is option A. Good question, guys. Two values of k are possible. K is equal to 1 or k is equal to 4. Hope this is clear, guys. Just multiply, use equality of matrices, equate the corresponding elements. You get the value of k. K will be equal to 1 or k equal to 4. Two values of k are possible. Let's move to the next question. Alright, now listen. I'm not going to do this problem in the normal regular method, what you do in the board exam, guys. follow this technique. You can use any question, any problem like this. Okay, use this technique for any matrix question. If I want to suppose to check what's the value of this determinant, right now, if it is true for x by z, then it should be true for any value of x by z. So I'm going to put x is equal to 0, y is equal to 1, and z equal to 2. Right? You put x is 0, y is equal to 1. You can assign any value, guys. I repeat myself. If it is true for x by z, then it should be true for any value of x by z. You always should pick any value, no issues. Alright, let me check what's the value of this determinant. Determinant of, I put x as 0, y as 1. So x plus y will be equal to 1. Y plus z will be equal to 3. Z plus x will be equal to 2. Again, x, y, z, 0, 1, 2. Okay, now x minus y is minus 1. Y minus z will be minus 1. Alright, and z minus x will be equal to plus 2. Okay, now let's expand this. Z minus x will be equal to plus 2. I check once again, guys. X plus y is 1, y plus z is 3, z plus x first and last is 2, 0, 1, 2. And then x minus y is minus 1, y minus z is minus 1, z minus x will be equal to plus 2. Let's do a double check. So this will be equal to 1 into, delete first row, first column, you will get this is 2 plus 2. Minus 3 into delete first row, second column, you will get this is 0, minus and minus is plus 2. Plus 2 into delete first row and last column, you get 0 plus 1. Okay, so this will be equal to 4 minus 6 plus 2. 4 minus 6 plus 2 will be equal to 0, guys. Answer will be option A. Good technique, na? You can use this for any question. Choose the value of x by z. If it is true for x by z, then it should be true for any value of x by z. If I substitute in the second option, you will get this as 0 plus 1 plus 2 the whole cube. Right, I'll get this as 27. That's why this is ruled out. Right, here also. Here I get this is 2 into, just now we found out this was 27. This is equal to 54. Okay, and then you get this is 2 into x plus y plus z, that is 0 plus 1 plus 2 the whole square. You get 9 into 2, 18. Answer is option A only. You understand, guys? Hope you appreciate this. Choose the values of x by z. If it's true for x by z, then it should be true for any value of x by z. Substitute in the matrix, substitute in the options, and check which of the following is true. Let's move to use this technique, guys. Use this technique. Very, very useful technique. Let's move to the next question. Alright, we have been doing in the previous classes. Alright, we have done this in previous class as well. It's a standard result that A into adjoint A is equal to determinant A into I. It's a standard result, na? A into adjoint A is equal to determinant A into I. So if I use this, determinant A is equal to 5. Okay, this is determinant A equal to 5. I am supposed to find out what is determinant of adjoint A. Determinant of adjoint A is equal to determinant A per n minus 1. N stands for order of the matrix. We have done in part 1, we have done in part 2. I am repeating, this is again in part 3. Determinant of adjoint A is always equal to determinant A per n minus 1. N stands for order of the matrix. Let me write here, N stands for order of the matrix. N stands for order of the matrix. Okay, order of the matrix is 3. That's already given, so n equal to 3. So if I substitute here, determinant A is equal to 5. And n stands for order of the matrix 3 minus 1. So you get this as 5 square. Right, that's equal to 25. Answer will be option B. Hope this is clear, guys. Determinant. So you are using two properties in this. A into adjoint A is determinant A into I. And we also use the determinant of adjoint A is determinant A per n minus 1. N stands for order of the matrix. Let's move to the next question. Okay, so see, again it is repeated. Same logic. It's repeated again. Again we have to find out same determinant of adjoint A. Determinant of adjoint A is equal to determinant A per n minus 1. In fact, you get such questions in boards only. CBSE, PUC, 1 marker, ISC. You get in one marker, you get board exam, board questions only. So determinant of adjoint A is equal to determinant A per n minus 1. Again, n stands for order of the matrix. Determinant A is equal to 8. Okay, n stands for order of the matrix. N will be equal to 3. So this becomes 3 minus 1. So this is 8 square. Okay, that's equal to 16. 1, that's equal to 8 square is 64. Sorry. Anyways, answer will be equal to 8 square. Answer is B. Yes, friends, let's move to the next question. Alright, very good question. Alright, now listen, follow carefully. I'm supposed to find out what is determinant of C, right, into determinant of adjoint of A, determinant of adjoint of B. Right, note the step now. This will be equal to determinant of, okay, determinant of 5 into A, and then this will be equal to determinant of, okay, adjoint of B. B is already given. B is equal to adjoint of adjoint A. Is it okay, guys? I'll take my time and explain you. Don't worry. All right, just follow carefully. So the value of C is given as 5A, so I substitute there, you get determinant of 5A, B is equal to adjoint of A, that's already mentioned in the question. So I have, see, we have done this in the previous classes. Whenever you have determinant of KA, and if I take that K out, constant scalar out, it will be K per N into determinant A. N stands for order of the matrix. So use the same logic, guys. If I take this 5 outside the determinant, it will be equal to 5 cube, okay, into determinant A. 5 cube into determinant A. Alright, right, 5 power n, right? Then we will substitute the values. It looks, alright, okay, fine. It looks more better now. I take 5 out, you get 5 power n. I'm using this result, alright? I repeat myself. I'm using determinant of K is K per n into determinant A. If you take scalar out, it becomes K per n into determinant A. So n stands for order of the matrix. Okay, now this becomes determinant of adjoint A. This becomes determinant of adjoint A. Alright, now n stands for order of the matrix. Order of the matrix is 3. Right, because A is a matrix order 3. Now I'm supposed to find what is determinant A, and I'm supposed to find out what is determinant of adjoint A. Okay, let me write this value matrix here once again. Matrix A is equal to 3 minus 3, 4. 3 minus 3, 4. And then 2 minus 3, 4. 2 minus 3, 4, 0, minus 1 and plus 1. Okay, let us cross check once again, otherwise we will not get. 3 minus 3, 4, 2 minus 3, 4, 0, minus 1 plus 1. Yes, I'm right. So let's find the determinant A. Determinant A is equal to 3 into delete first row, first column, you get minus 3 plus 4. Okay, minus now, minus and minus is plus 3. Delete first row, second column, you get 2 minus 0. Plus 4. Delete first row, last column, you will get this as minus 2, okay, minus and minus 0 or plus 0, what it may be. So this will be anyways, this is plus 3, okay, plus 6, minus 8. So determinant A will be equal to 1. Determinant A is equal to 1. And I taught you this previous classes, the determinant of adjoint A. Determinant of adjoint A is always equal to determinant A per n minus 1 the whole square. We have done in part 1 and part 2 as well. Right? Previous case set questions we have done, guys. Determinant of adjoint A is determinant A per n minus 1 the whole square. N stands for order of the matrix. So this will be equal to determinant A is 1. Anyways, I'll substitute there. N stands for order of the matrix. We got n equal to 3, right? So if I substitute here, you get 3 minus 1 the whole square. So this is determinant A power 4. 3 minus 1 the whole square, 4 only now. Determinant A is 1. Anyways, 1 per something is 1 only. So what am I getting? Determinant A 1. Determinant of adjoint A is also 1. So this is n stands for order of the matrix. So this is 5 cube. Determinant A was 1. Determinant of adjoint A is also 1. You get this as 5 cube. That is 125. Answer is option A. Hope you understood, guys. Very good question. Right, very good question, guys. But you have to use this formula. You have done in complex numbers in class 11th. If omega is a cube root of unity, right? You have done in class 11th. Okay, you've done in class 11th. What is cube roots of unity? Let me just brush this once, and then I'll go to the question. Class 11th. So they usually they will blend the topics, guys. They'll blend the concepts and then give you a question. So question based on this. So they mix complex numbers plus determinants and then given a question. Cube roots of unity is 1, omega, and omega square. Alright, the value of omega will be equal to minus 1 plus I into root 3 upon 2. And value of omega square will be equal to minus 1 minus I into root 3 upon 2. You have to remember these two. That's the value of omega and omega square. Okay, there are some more results. 1 plus omega square is always 0. If you want to add this plus omega, you get 0 only, guys. 1 plus omega square is always 0. From this we get another three results. 1 plus omega is minus omega square. 1 plus omega square is minus omega. And omega plus omega square is equal to minus 1. So you get 3 results from 1 plus omega square. Right, now listen. Omega cube is 1. Right, omega cube is 1. If you have suppose omega power 4, omega power 4 can be written as omega cube into omega. Omega cube is 1. Omega cube is 1, you get 1 into omega is equal to omega. Omega to the power of 5 will be equal to omega cube into omega square. Omega cube is 1, guys. You get 1 into omega square will be equal to omega square. Right? Similarly, omega power 6 is omega cube the whole square. Right? Omega cube is 1, so this is equal to 1. In general, omega per multiple of 3 is always equal to 1. Omega per multiple of 3, omega per 300 will be 1. Omega per multiple of 3 will be 1. Omega per 123 is also equal to 1. Omega per multiple of 3 is always equal to 1. So let me use this. So this is what I want to introduce about the cube roots, which I've done in class 11th, the first year State Board first PUC CBSE class 11th you have done in ISC as well. Complex numbers, cube roots of unity. Okay, now if I solve this question, guys, take this determinant. Alright, now follow carefully. I'm going to add the first column and the second column. Okay, let me add first column and the second column. So this becomes 1 plus omega square. Okay, and then if I add the first column and the second column, omega square plus omega minus omega, and then you get 1 plus omega square, okay, plus omega. Add the first column and the second column, so this fellow becomes omega square minus omega, this is omega, last column will be equal to omega square, and then this is omega square, this will cancel. Alright, so this is equal to determinant of, just now we have done 1 plus omega square is 0. So this is 0. Here I have omega square. Even this fellow is 0. Second column will be equal to omega square minus omega. This is omega. Last column will be equal to omega square and omega square. Right. Let's expand this. Right, let me do it here. 0 multiplied by number is 0 minus omega square. Right, delete first row, second column, you get omega power 4. Omega power 4 minus 0. Yeah, plus omega, delete first row, last column. If I delete first row, last column, you get omega cube, right, minus 0 or plus 0, whatever it may be. Right, so this becomes, anyways, this is 0. Anyways, this is 0. This is minus omega square into omega square into omega power 4 is omega power 6 plus omega into omega cube is 1. I just now told you omega power 3 is 1. Omega per multiple of 3 is 1 in fact. Omega power 6 is 1. We have done here, friends. We have done omega power 6 is 1, guys. Omega power 6 is 1. Omega cube is 1. So left out is minus 1 plus omega. The same as omega minus 1. Answer is option B. Good question, now. So they miss. So I've done the basics as well, guys. What is cube root of unity? 1 plus omega. What's the value of omega? What's the value of omega square? I've done. You need that in complex numbers as well. So we have done this, right? So please watch this recording, guys. Watch the YouTube video once again and complete your notes. Let's move to the next question. Okay, I'm supposed to find the value of z. It's given in the question that A into X is equal to matrix B. Matrix A is equal to 1, 1, 1, and then you get this as 1, 2, 3, and then you get 1, 3, 4. This is matrix A. Right, now matrix X will be equal to, matrix X is equal to X, Y and Z. Okay, is equal to matrix B. Matrix B will be equal to 7, okay, and then 16 and 22. Alright, let's multiply, guys. Let me write this properly. Alright, so 7, 6 and 22. Alright, let's multiply. First row, first column. You will get this as X plus Y plus Z. Right, multiply first row and second row, first column. You get this as X plus 2Y plus 3Z. And second row, third row, first column will give me X plus 3Y plus 4Z. Okay, the plus 4Z. Alright, is equal to matrix. Is equal to matrix 7, 16 and 22. Okay, now let's equate, guys. If I equate the corresponding values, I get this as X plus Y plus Z. X plus Y plus Z is equal to 7. And then you get this as X plus 2Y plus 3Z. 3Z is equal to 16. And this becomes X plus 3Y. X plus 3Y plus 4Z. Okay, is equal to 22. This is equal to 22. Right, I have to solve all this and take the value of Z. Don't use matrix method. Right, follow carefully. Let's call this equation 1. Let's call this equation 2. Right, let's call this equation 3. I'm going to subtract equation 2 minus equation 1. Right, if I subtract equation 2 minus equation 1, X will get cancelled. 2Y minus Y is equal to Y. 3Z minus Z will be equal to 2Z. Is equal to 6. Is equal to 16 minus 7, you get 9, na? Okay, and then I'll subtract equation 3 minus equation 2. Equation 3 minus equation 2, if I subtract, again X will cancel, X will eliminate. 3Y minus Y will be equal to Y. And then 4Z minus 3Z will be equal to Z. Again, if you subtract, guys, 22 minus 16 will be equal to plus 6. Okay, now it is easy. Now I'm supposed to find the value of Z now. Let's call equation 4. Okay, and let's call this equation 5. We'll subtract equation 4 minus equation 5. Or you subtract 5 minus 4, no issues. You subtract, Y will get cancelled. 2Z minus Z is equal to Z. Is equal to 9 minus 6 will be equal to 3. So the value of Z should be equal to 3. Convinced, guys? Hope this is clear. The value of Z will be equal to plus 3 only. Answer is option D. Alright, so don't use matrix method, guys. It takes a lot of time. Right, just subtract them consecutively. 2 minus 1, 3 minus 2, and again you subtract them, take the difference, you get the value. Z will be equal to plus 3 only, guys. Good question. Let's move to the next question. It's not a unit matrix, right? Because secondary diagonal elements are 1. So first let us first find a square now. A square is equal to a into a. Matrix A will be equal to 0 1 0 0 1 0 1 0 and 1 0 0. Even this matrix will be equal to 0 0 1 0 1 0 and 0 1 0 0. Right, so this is 1 0 and 0. Multiply row and column. Okay, first row, first column will give me 0 plus 0 0 plus 0 plus 1. First row, second column will give me 0 plus 0 plus 0. First row, last column will be same 0 plus 0 plus 0. Second row, first column will give me 0 plus 0 plus 0. Second row, second column 0 plus 1 plus 0. Second row, last column 0 plus 0 plus 0. Third row, first column 0 plus 0 plus 0. Again you will get this as 0 plus 0 plus 0. Again this will be equal to 1 plus 0 plus 0. Now it's easy. I get actually unit matrix. I get this as 1 0 0. Right, 0 1 0 and 0 0 1. I get this as unit matrix I. Okay, now a power 4. I'm supposed to find what is a power 4. A power 4 can be written as a square into a. A square is I, right? Again a square is I. I into I, unit matrix will be equal to I only. Answer is option A. Hope this is clear, guys. Excuse me. Let's move to the next question. Okay, let me remind you once again. Right? If suppose matrix which is equal to its own transpose, A transpose is equal to A, then A is called symmetric. Then A is symmetric. Am I right, guys? A matrix which is equal to its own transpose is symmetric. Okay, a matrix which is equal to negative of its own transpose. A transpose is equal to minus A, negative of its own transpose, then it is called skew symmetric. Negative of its own transpose, then it is called skew symmetric. Matrix which is equal to own transpose symmetric, negative of its own transpose, then it is called skew symmetric. Alright, if I use this logic, it is given in the question that A and B are symmetric matrices of same order and B is skew symmetric. So B is skew symmetric, B transpose is equal to minus B. Right, that's already given in question, guys, that B is skew symmetric. A matrix which is equal to negative of its own transpose should be equal to skew symmetric only. So B transpose is equal to minus B. Now you have to check what is A dash B into A. Right, now whether it is symmetric or skew symmetric, null or diagonal. I'll take the transpose of this. Okay, I take transpose of this. We know that reversal law of transposes now. Whenever you have AB whole dash will be equal to B dash into A dash, that is reversal law of transposes. So this can be written as A dash, right, and then B dash and then A dash of dash. So this will be equal to A dash, this is B dash, A dash of dash is A. Right, we know that B dash is equal to minus B. That's already mentioned, initial condition, because B is skew symmetric, right? B dash is equal to minus B. So this becomes minus A dash B into A. Right, let me write here, since B dash is equal to minus B, that's already mentioned that B is skew symmetric. So what am I getting now? A dash B and A whole dash is equal to minus A dash B and A. So it is equal to its own transpose, right? Negative of its own transpose. Therefore, okay, therefore A dash B and A is skew symmetric. This is skew symmetric. Answer is option B. This is skew symmetric. Answer should be B only. Let's move to the next question, guys. Question number 62. Yeah, this is KSET 2020 question. Okay, this is KSET 2020 question. I am supposed to find out what is matrix A. Alright, now follow carefully. This can be written as 2, 1, 3, 2. Okay, and then this is A. Right side you get unit matrix type. Right now, if I take this as B into A is equal to I, follow carefully. Right, what did I take, guys? I've taken B is equal to matrix 2, 1, 3, 2. Don't worry, I'll replace later. Right, so I've taken this as B. So I'm taken matrix B is equal to 2, 1, 3, 2. I'm supposed to find out what is A, right? Now operate B inverse on left. Operate B inverse on the left side. So if I operate B inverse on the left side, this becomes B inverse into B, right, into A is equal to B inverse into B. Don't worry about the grouping on the left side. Matrix multiplication is always associative. I just operated B inverse on the left side. B inverse into B is equal to I. Okay, into A is equal to B inverse. B inverse into I. I into A is equal to A. Identity matrix multiplied with any matrix to get back the same thing. So B into I is equal to A. B inverse into I will be equal to B inverse. Now matrix A is equal to, we'll find out what is B inverse, guys. We took B now. B is equal to matrix, how much is this? 2, 1, okay, 3, 2. Determinant of B. B inverse is 1 by determinant of B into adjoint of B. Determinant of B will be equal to principal minus secondary. 4 minus 3, that's equal to 1. So determinant of B is 1. Adjoint of B. How do you find the adjoint? Interchange the diagonal elements, so you get back the same thing. Interchange the diagonal elements and change the sign of other elements. Plus 1 will become minus 1 and plus 3 will become minus 3. Okay, now this is equal to 2 minus 1 minus 3 and 2. You get 2 minus 1 minus 3 and 2. 2 minus 1 minus 3 and 2. Answer will be equal to option D. Good question, guys. 2020 question. KSET 2020 question. Alright, let's move to the next question. Okay, question number 63. Again this is KSET 2020. This is KSET 2020 question. Alright, I'm supposed to find out which of the following is true, guys. See, if I look into the question based on the observation, alright, based on the observation, if I take suppose f of 0, right, or if I go with the options, first option f of 0, in place of x if I put 0, right, this will be equal to 0, A and B. This is minus A, 0 and C. This is equal to minus B, minus C and 0. Right, now this is skew symmetric now. Determinant of a skew symmetric matrix of odd order. Determinant of a skew symmetric matrix of odd order. Odd order is always equal to 0. Is always equal to 0. Alright, this is skew symmetric only, guys. What is skew symmetric? See, if I want to write an example of a skew symmetric, right, principal diagonal elements should be 0. Right, everybody on the platform, guys. So principal diagonal elements should be zeros. Elements which are symmetric to the principal diagonal should be same but opposite in sign. If I take this as 1, 2 and 3, alright, this should be minus 1, minus 2 and minus 3. Elements which are symmetric to the principal diagonal are same but opposite in sign, that is skew symmetric. And determinant of a skew symmetric matrix of odd order is always 0. What you fold this, assume that as a paper and fold, elements will coincide. 1 minus 1, 2 minus 2, 3 minus 2. I repeat myself, you assume that as a paper and fold. When you fold that, elements will coincide. 1 minus 1, 2 minus 2, 3 minus 3. only then this is skew symmetric, and determinant of a skew symmetric matrix for order 3 is always equal to 0. So this will is skew symmetric, principal is 0, and you fold these elements will coincide with plus and minus, so determinant is 0. Answer is option E only. Good question guys, 2020 question. Let's move to the next question. Okay, even this is case at 2020. There were total 4 questions which were asked in 2020 paper on matrices and determinants. If that is hiding, if you cannot see that guys, skew symmetric matrix, I'll just give you an example of a skew symmetric matrix once again. This is skew symmetric. Okay, this is an example of a symmetric matrix. What is symmetric matrix? If I take principal as principal, you take anything. Suppose I take 5, 7, 9. You take principal as 5, 7, 9. Elements which are symmetric to the principal diagonal. If I take this as A, B, C, even this should be equal to A, B, C. You assume this is a paper, and you fold this, elements will coincide. That is matrix which is equal to its own transpose is called symmetric. I repeat, assume this is a paper and fold, elements will coincide. Alright, now if I take a skew symmetric matrix, principal diagonal elements should be zeros. Elements which are symmetric to the principal diagonal should be same but opposite in sign. If I take 5, 7 and minus 9, this should be equal to minus 5, minus 7, okay, and then plus 9. You assume this is a paper and fold, elements will coincide. 5 minus 5, 7 minus 7, 9 minus 9. So this is matrix which is equal to its own transpose. This is skew symmetric. Hope this is clear guys. Hope this is clear. What do you mean by symmetric, skew symmetric? So determinant of a skew symmetric matrix for order 3 or odd order is always equal to 0. Okay, now before I take the question guys, okay, now listen, I just give you a good trick guys, good technique. Suppose you have a determinant. There are some previous MCQs on CET as well, previous case at MCQs as well on this concept. The 2020, but most people got confused with the options. Okay, now let's say if you have suppose like this 2001, 2002, 2003, 2004, just an example guys, 2004, 2005, 2006, 2007, right, 2008 and 2009. Value for determinant is always equal to 0. How will I know that? Arrangement of numbers in a determinant are in AP. Value for determinant should always be equal to 0. If I want to prove it, 3 by 3, alright, not 2 by 2. Change R2 to R2 minus R1. Change R2 to R2 minus R1 and change R3 to R3 minus R1. Right, if I subtract guys, first row will be equal to 2001. This is 2002. This is 2003. If you subtract, you will get this as 3, 3 and 3. If you subtract this, you will get this as 6, 6 and 6. Second row, I'm going to take 3 out. Last row, I'm going to take 6 out. Okay, so this is 2001, this is 2002, this is 2003. Right, and then this is equal to 1, 1, 1. And then you get this as 1, 1, 1. Two rows are identical, guys. Answer will be equal to 0. Right, now I repeat myself, if the arrangement of numbers are in AP in a 3 by 3 determinant, the value for determinant is always 0. Same logic. A1 to AN is in AP, na? A1 to AN is in AP, that's mentioned in the question. So this means that A1, A2, A3, A4, A5, A6, A7, A8, A9, all are in AP. Value for determinant is 0. Right? This is what people got confused. I've seen even the good ones getting confused with this. Determinant is 0. So how will I know that? Log e to the base is 1 only, na? Yes guys, logarithm of a positive real number to the same base is 1. Log 2 base 2 is 1. Log 3 base 3 is 1. Okay, so log 1 to any base is 0. Log 1 to any base is 0. Answer will be equal to option A only. You understand guys? So that's why log E is 1, log 1 to any base is 0. Answer will be option A only. That's what people just to request us to state. Don't worry. But whenever you have arrangement of numbers in AP, in a 3 by 3 determinant, value for determinant is 0. That example I have given here. Okay, let's move to the next question, guys. A is a square matrix order 3C. We have done so many questions like this. A into adjoint A. A into adjoint A is always equal to determinant A into I. Okay, so I'm supposed to find out what is A into adjoint A now. So this is A into adjoint of A. A into adjoint of A is equal to determinant A into I. Right, so this is equal to determinant of det of determinant A is 5. 5 and then this is equal to I. Right, as we have mentioned in today's session, we have done in previous classes as well. Whenever you have determinant of K, scalar times the determinant A, okay, you take outside, you get this determinant K per n into determinant A. N stands for order of the matrix. 5 to the power of n into determinant A. Alright, so this is equal to 5 power n. N stands for order of the matrix, guys. N is equal to 3. So this becomes 5 cube into determinant I is 1. 5 cube is 125. Okay, answer is option D. Hope this is clear, guys. Right, let's do another couple of questions. Okay, I'm supposed to find out what is the value of x comma y. Okay, let's multiply, guys. Okay, first row, first column, you get minus 2x plus 5y. Second row, first column, you will get this as 3x minus y. Okay, is equal to matrix, you will get this as 3 minus 2. Second row, first column, you will get this as 9 minus 4. Let's equate them, guys. Minus 2x plus 5y. Okay, and then this is equal to 3x minus y is equal to matrix 1 and 5. Okay, now let's equate them. You will get this as minus 2x plus 5y. Okay, is equal to 1, and 3x minus y is equal to 5. Either use elimination method or you use the simultaneous linear equations, or you do that substitution method, you get the same answer. Otherwise, you take the option, substitute there and check which will satisfy, guys. 3x minus 5 is equal to y. Okay, now I substitute here, you get minus 2x plus 5 into y value will be, y value is 3x minus 5. Okay, is equal to 1. Minus 2x plus 15x, right, minus 25 is equal to 1. You get 13x is equal to 26. 26. 13x is equal to 26. Okay, and x is equal to 2. X is equal to 2. If I substitute here, you get y is equal to 1. X equal to 2, only one option. This is ruled out, this is ruled out, this is ruled out. Answer is option D. So thanks for joining, guys. We will continue the next session. So before I wind up, if you like my video, guys, please do subscribe and enable the bell icon. Whenever I go live, right, you get the notification of my classes, guys. If you are new here, I repeat myself. Let me tell you once again, I welcome you for this live session, guys. Thanks for joining me. Thanks for joining me, guys. So just a moment before I wind up, right? Let me just remind you, it's a general reminder once again, guys. It's a general reminder once again for the Unacademy subscription, right? Now I'll tell you why do you need to take the subscription, guys. See, per month is 12375. That is 103131 per month, right? And then enter this referral code, you get 10% discount. 10125, that is 1688 per month for 6 months. Okay, that is per month 1688, and per month 2250. That's a throwaway price in Bangalore. Enter this referral code, you get 10% discount. You get premium content at affordable prices, structured live courses, quizzes at regular intervals, batches for complete preparation, test series for DPPs. You get all this in a single subscription for unlimited access. Guys, let me tell you once again, if you're looking for the top 10 engineering colleges in Karnataka, PESIT, UVC, RV, BMS, MS Ramaya, Dayanand Sagar. If you're looking for top 10 engineering colleges, guys, your ranking should not exceed 2000. And believe me, approximately 2 lakh people are writing KSET across Karnataka. and your ranking should be damn good, guys. And free seat, 48,500 rupees only. You understand? Payment seat, it depends on the college, guys. It costs you at least 10 lakhs, 12 lakhs per annum, plus the donation, other things and all. So we are all middle class, guys. No, middle class people cannot afford that fees, guys. So I tell you guys, I request you guys, I'm motivating you guys online. So you work hard, guys, and take this subscription. Work hard. You understand? Don't miss the classes. Work hard, guys. Minimum 6 hours a day. So work hard. Your ranking should not exceed 2,000. Payments is very costly, guys. Free seat is only 48,500 plus. It depends the college. They take some college take 20,000 plus. Some college take 30,000. Take an academy subscription and work hard. There are more than 40 top educators of India, guys. It's number one online platform in India. Thanks for joining, guys. I'm going to continue with part 4 in the next session. Thank you, guys. Thank you once again. God bless you, guys. Bye. Take care.